Hello everyone and welcome to a tutorial on how to use 9p protocol in Proxmox virtual environment. So what is 9p protocol? It is actually a network protocol designed to exchange messages between client and server, and it also functions pretty well as a network file system. It was first introduced in Plan 9 from Bell Labs, which is actually a kind of forgotten and underrated operating system, which was created in early 90s by the same people who created Unix. And one of the design choices was to basically make computers more decentralized. So for example, there will be one computer doing actually computing, a computer for the file system and other stuff. 9p was actually a protocol designed to exchange these files over the network. It's pretty simple and designed, of course, to be really fast. But I have to tell you something, I wasn't really saying the whole truth about 9p, because what I'm actually referring to a 9p protocol is today 9p 2000. So the version of this protocol that was revisited for the fourth final release of Plan 9 operating system. Even more confusing is the fact that we have 9p2000.u, which is the dialect that adds extensions for Unix systems, and 9p2000.l, which adds these extensions for Linux. But you don't have to worry about it. I think two of those are supported by QEMU, and the differences are really subtle. As a fun fact, I will tell you that 9p is actually used in the wild. It's used in Nix package manager and WSL, so Windows subsystem for Linux, since Windows 10 version 1903. But what we are gonna focus today is this, so QEMU. QEMU has a really good support of 9p file system, so we don't have to install anything inside Proxmox. Proxmox already uses QEMU for the virtualization part. Okay, so now you know the history, but what we are trying to achieve? What can this protocol give us? So as you can see, I have two virtual machines here. Both of these have a virtual disk. So what that means, this disk is actually a large 32 GB file stored on the ZFS file system in my Proxmox instance. So as you can see here, I have two virtual disks. Each one is a separate ZFS dataset, but I can't mount it because it's just a large file. And why is that a problem? Firstly, you might want to access some files from your VM in your host or vice versa. So when you create a file on the host, for it to appear also in the guest file system. And the another more important part is actually the performance. So I have two SSDs here configured in mirror. So for me, the performance probably is okay, even if I use these virtual disks. But you have to remember that when you are installing your guest operating system, it actually treats this file as a disk. So it creates partition, file systems, and everything it needs to function inside this file. And honestly, that's not good, because we already have a file system, we have ZFS. So why creating two file systems? It obviously will be faster to have one, right? And while that's true, it's pretty hard to install 9p as a root file system, but there's a guide over here. You can read it if you want, but I haven't tried that yet. It looks complicated, honestly. Today we will just share a directory from the host and it will be accessible inside our guest. So we'll now create a ZFS dataset to store these files shared with our virtual machines. I want to create a dataset with a mount point of /9p share. So this is inside Proxmox with ACL type equals POSIX ACL that allows storing extended POSIX access control list metadata, which is used by OpenMediaVault, for example. Xarcher equals SA attaches those ACLs directly to an inode, which should improve performance. And ACL inherit equals passthrough means that ACLs are inherited without any changes to new objects in directory. And now, of course, the name of our dataset. Okay, so as you can see here, we have our dataset created. Now I will create a regular directory inside it, just to separate the virtual machines that will be sharing files. So as you can see here, I have two directories, and now we can give access to them, and we will do that by editing the configuration files. Firstly, I want to edit this virtual machine with the ID 101. As you can see, that corresponds. We need to add a line that says args I will now explain what these parameters mean. So virtfs, like we are adding a virtual file system, the storage driver is local, and I recommend you keeping that. The path is a path inside our Proxmox, so our dataset 9p share and the directory will be shared. The mount tag is a unique tag when you have more than one virtual file system shared to the guest. You can differentiate between each other. Security model equals mapped xatr. This actually means certain file attributes like UID, GID are stored as file attributes, and that's slightly more secure than just pass-through and letting the virtual machine set those values for themselves on host. And ID is a unique identifier for fsdev device. So we can save that file, Ctrl X, Y, and enter. And that's pretty much it on the host. Now we'll fire up our virtual machine and add an appropriate entry inside the FS tab. Okay, so the virtual machine is running, but the text is so small. Let me just SSH into it and I will show everything you need to do. So as you can see, this is OpenMediaVault, but it's actually Debian underneath. So we can edit nano etc fstab, and we'll add an entry here. So it should look like this. We have 9p share, which is our mount tag, and then we have the directory in the guest that we need to create, of course, and this will be the directory the guest will access in order to share files with the host file system. Then we have type 9p, then options, so transport, I think, virt.io, so that's the QEMU virtual file system, version 9p2000.l, so the Linux extension, no boot weight and RW. I'm not sure, honestly, but I think this means that operating systems do not have to wait to boot for this mount entry, and RW just means read and write. Now the M size parameter, it's actually pretty important. This sets the maximum message size that 9p can send over the network. It's internal network, of course, but 9p is still a network protocol and it has a limit of the maximum message size. But I think a half megabyte should be enough. And then user exater and POSIX ACL. So those are the things related to the access control list. And this netdef, I think this tells the operating system we have to have a network configured and then mount this entry. Okay, so that's all. But now we won't try to mount this fstab yet. We have to create the directory, as you might remember, and I will do that with OpenMediaVault plugin share rootfs. So here I am inside my OpenMediaVault. It's really a blank installation, I haven't done anything yet. So plugins share rootfs. And as you can see, now it's installed. And what we'll do is to actually go into storage, shared folders, and as you can see here, we have our root file system available. Now the path will be storage 9p share, so exactly the same we have in our fstab entry, and the name I will give 9p share. Let's just confirm this folder exists. Now we'll try to mount the fstab. And as you can see, we haven't got any errors. So when you do df -h, we actually have our host file system available for us. And what's more interesting, we can create a file in it. It will obviously show up here, but what's not so obvious, we can actually access it inside our Proxmox. And we can echo some data into a file. So that's done from the host. And that's from the guest. Now, please don't treat it as an OpenMediaVault tutorial, but I will now try to configure SMB share to work with our shared directory. Okay, so I forgot to turn on the file server. And now it is working. So as you can see, we have two files. This one is created from the host, this from the guest, and I will try to create another one. Okay, so I was able to save this file, so we've got no permission issues whatsoever. And as you can see, this file is 16 bytes, and we can read it from here, but also from here. And now what's left to do is to do the same steps for the other VM, and I will try doing some benchmarks on it. So as you can see, we have our virtual file system mounted correctly. Now I will try to benchmark both the 9p virtual file system and my benchmark drive. As you can see here, I have mounted the benchmark partition, which is just an ext4 partition on this virtual disk, and I also have my 9p share mounted. Here is the command I'm gonna use to benchmark. You need to have FIO utility installed, and as you can see, the benchmark will be a write throughput, so I think this is the same as sequential write. The directory is 9p share, numdrops is 4, and size of a single chunk is 4 gigabytes. So in total this will give us 16 gigabytes of data written to the disk. And the runtime is 180 seconds. Let's start with benchmarking 9p share. Okay, so benchmark's done. And as you can see, we've got almost 92 megabytes per second write speed, and in terms of IOPS we have 519. So now we'll benchmark the other drive, so the traditional virtual drive that I created in Proxmox. It's mounted under /mnt. Okay, so as you can see, the second benchmark also finished, and the results are quite a bit different. I decided to make this benchmark on other drive than a root, because benchmarking the root partition would be kind of unfair, I think. But this is not root partition, and we got only 41 megabytes per second. And that's the file system overhead. When you are writing to a virtual drive, your CPU has to do much more operations. In terms of IOPS, we have only, as you can see here, 62 IOPS. So I hope this tutorial was useful, and if you are interested, there's a blog post which is the entire basis of today's video. But it's unfortunately only one blog post on nerding.es, and it's not even in English. It also tells you how to create a ZFS dataset and then mount it inside the guest operating system using 9p. Honestly, I think when you are using OpenMediaVault running inside Proxmox, this is your best option. Like when you have the virtual drive here, you don't really have any control over the guest file system. So the performance could be not great, and also there is that thing with ZFS. It has the record size property, and I ran into an issue on my Proxmox instance when the virtual disk got even larger than it was. Like in terms of the used space on ZFS, I had like 900 gigabytes when in fact the hard drive was only 600 and there was like 200 gigabytes used, so that was pretty wild, and I think using 9p could avoid such situations. Anyway, thank you for watching, and I hope my tutorial was useful.